What is the smallest unit of matter has been a question that has been posed at least since the ancient Greeks, but it is only recently that a clear answer can be given. Physicists now know that atoms are the basic building blocks of all matter, living or non-living. Each atom is made up of electrons that spin around a nucleus made up of protons and neutrons. Atoms are so incredibly small, they have been very difficult to study, but all atoms are roughly the same size, no matter how many electrons they have. If the atom is small, the different parts of an atom are a fraction of its size. Picture the nucleus, about the size of a marble, in the center of a soccer field. The electrons would be the size of a speck of sand at the goalposts. The rest of the atom is empty space. The nucleus itself is made up of protons and neutrons, collectively called nucleons. Protons possess a positive electrical charge, and neutrons have no charge. Since electrical charges that are the same repel each other, why is it that a nucleus does not fly apart? It is the strong nuclear force between the protons and neutrons that holds it together. The protons give the nucleus a positive charge. Despite its small size, the nucleus is very dense and contains most of the mass of the atom. The protons and neutrons in the nucleus are actually made up of even smaller particles called quarks. There are 6 different types of quarks, but only 2 occur in atoms. The others exist only in unstable particles. Quarks and electrons are considered to be the smallest units of matter in the universe. The force that attracts the electrons to the nucleus and binds the atom together is the electromagnetic force. Opposite electrical charges attract each other, and it is that attraction that holds the electrons in their orbits around the nucleus. The negative electrical charges of the electrons balance the positive electrical charges of the protons, making the atom electrically neutral. If atoms were visible, the electrons would appear as a cloud, dense in some parts and thin in others. Early models of the atom compared the movement of the electrons to planets orbiting the sun, the so-called planetary model. It is now known that the actual movement of electrons is much more complicated. Electrons spin. They have an electromagnetic charge and are subject to the forces of gravity. But they also act like waves, moving together around the nucleus in complicated patterns called orbitals. Physicists have calculated mathematically where electrons are likely to be found as they orbit the nucleus. This animation is a 3D representation of those probability calculations. The brightest regions represent the highest probability of the electron's location, and the darkest regions the lowest probability. For different energy states of the electrons, the patterns of probability become more and more complex. Experiments have proven that it is impossible to know both the precise location of an electron and its speed at the same time. This is known as the uncertainty principle.